Hi there. Here we are, section 6.4. I'm going to look at question 25 and 27. I'm going to save 31 for another video because it's a little bit more complicated. On page 300. So the question says that birth weights, so baby weights, are normally distributed with a mean of mu, this little thing there, that's mu, you're probably used to that, equal to 3285 grams, and a standard deviation of sigma equal to 500 grams. So again, that's sigma, that little O-shaped thing. And question 25 says, what is the probability of a birth weight equal to 3285 grams? Question 27, what is the probability of a birth weight of at least 3285 grams? Oh, those at least ones. So from chapter 5, the at least probably turns your blood cold, but in this situation, it's not that confusing. So I have a pretty picture waiting for you. Look at this. Ta-da! I got tired of trying to draw the normal curves by hand, so I'm going to use some internet ones for now. So question 35. Let me get my pen up. Says, what is 25, sorry. What is the probability of a birth weight equal to 3285 grams? Okay, so here's our normal curve, right? Oh, I need a fatter line. So we know this is X is the baby weights. X is normally distributed with a mean of 3285 and a standard deviation of 500. Okay, so I can put the mean right here. I'm going to use a straight line tool. There, that's our mean, roughly. Sorry, it's not perfectly straight. I apologize to you guys. So the mean right here, that's mu, equals 3285. Because this is symmetric, the mean is equal to the median, and the mode, it's right in the center. The mean's always right in the middle of these normal curves. So equal to 3285 grams. This is sort of a trick question because the probability that a birth weight is equal to that is the area of a line. What? So probability is the area under the curve, and we always deal with intervals in this case. We don't have an interval, we just have a line. So the probability equals 0. So it's basically saying that it's very unlikely that a baby will weigh exactly 3285 grams. They're more likely to weigh 3285. What if they add a tiny, tiny, tiny little bit, 0.00000? They have an extra long hair, 1 grams. So they're saying the probability that they weigh some exact amount is so small on a continuous curve that it's effectively 0. Mathematically, it's the area of this line, which is 0. So just remember that for these continuous random variables, probability equals area under the curve. That's kind of the takeaway for that question. That's why they tricked you. Probability equals area under the curve. So you need an interval to get an area. What is the probability of a birth weight of at least 3285? Ah, at least. Can we change colors? So at least 3285 means 3285 or more. So everything from here on up is at least 3285 grams, right? So in order to shade this in a beautiful way, I'm going to draw a little line there, like that. Sometimes this little fill tool doesn't really work unless it's all closed. Ta-da! That's the probability of at least 3285 grams. Well, we don't really need the empirical rule for this one. We can just use the properties of the normal curve and see that everything on this half, that's half the curve, right? It's symmetric, is 0.50. So this answer, I better go back to, I'll go red, maybe we can see the red, equals 0.50. So these two problems were, one was just tricking you with, oh, you have to remember that the probability that it equals one value is 0. So we're always dealing with intervals, not a specific value. And what is the probability of at least 3285 was just half the curve, so that's 50%. So I'm going to do question, I believe it's 31 on the next video, and 31 is harder. So this one, you can take a moment and feel really good about yourself before you head into the more challenging problem.